And now we are going to learn about the second type of selection, which is the directional selection. Directional selection is natural selection that produces a gradual change in allele frequencies over several generations. This usually happens when there is a change in environment, selection pressures, or a new allele that has appeared in the population that is advantageous. This curve has a mean that represents the optimum value for the phenotypic character under the existing conditions. Now, if the environmental conditions change, so will the optimum value for survival. Some individuals, either to the left or to the right of the mean, will possess a combination of alleles with the new optimum for the phenotypic character. As a result, there will be a selection pressure favoring the combination of alleles that results in the mean moving to either the left or the right of its original position. Let's take an example to really understand this directional selection. Suppose there is a recent finding has shown that climate change is having an effect on fish size in certain habitats. Now, the increase in temperatures is selecting for a smaller body size and against a larger body size. The larger fish have greater metabolic needs than the smaller fish, and so they will feel the effect of increased temperatures more strongly. What about the fish with a smaller body size? Well, fish with a smaller body size are therefore fitter and better adapted to living in seas experiencing increased temperature. This means that the fish of a smaller size are more likely to reproduce and pass their alleles to offspring. Over generations, this will lead to an increase in the frequency of alleles that produce a smaller body size and decrease in the frequency of alleles that produce a larger body size. Therefore, we can conclude that directional selection results in one extreme of a range of variation being selected against in favor of the other extreme, or even the average.